Since NASA announced the landing of the first human on the moon, some people doubt if this landing really happened and wonder if what they see in NASA's reports is actually our moon.
Yes, I said it, the moon.
Others are even skeptical about the purpose of going to the moon.
The reason those guys wanted to go to the moon is they were all married.
But the amazing thing is how they were able to do it without computers.
Hard work.
You said hard work?
When NASA was at its height and the space race was in full swing, electronic calculators were not yet developed. This meant that everything, even the calculations required to send a man to the moon, had to be done by hand. Engineers would use ladders to write on the highest chalkboards at NASA headquarters because of the enormous number of calculations that had to be made. They used to work out difficult mathematics while standing on a ladder and writing on a chalkboard, where any mistake can ultimately result in a rocket crashing. Before the advent of computers, NASA employees would have to use far more time-consuming methods, such as chalkboards, to convey their knowledge. The scientists calculated complex spacecraft trajectories, navigation, spacecraft orbits, and much more using math and physics. The computations took a lot of time and effort. For this snapshot, it's likely that those scientists were asked to fill the board with complicated equations. There is nothing unique about these generic equations of motion. There are only reference equations on that board, there are no calculations there. Fair enough, given that the space race was in full swing, no more should be expected. The term computer originally referred to people rather than machines before the invention of electronic computers. It was a title for a position that denoted someone who manually conducts mathematical computations and equations.
So meat computer can calculate.
Long and usually tedious computations were frequently completed by teams of workers. The task was divided so that it could be completed simultaneously. Many times, highly developed electromechanical devices were developed to assist. The eminent NASA scientists would hold math parties for a difficult equation that deals with time steps and feeds back on itself. Everyone would be able to solve one problem component. After the first guy completed his task, he would pass it on to the second guy, and so forth. The last individual would eventually return to the first person and give him the updated inputs for 1 millisecond further in the time. After a few hours you may have a nice, neat graph showing everything over a 1 to 2 seconds period. The first nuclear reactors, nuclear bombs, and many aerospace calculations were all carried out in this manner. Every line of code required to control the shuttle was placed onto a computer with 64 kilobyte of RAM operating at 0.043 MHz after all the physics were all worked out. Comparing that to what the mobile phones we have today, we can understand a little bit of perspective of just how incredible the moon landing was. In this instance, modern technology makes these complex calculations go by like a breeze. It is likely that everything these engineers were working out on this giant chalkboard could be reduced to a simple computer program nowadays. The secrets of the first trip to the moon in the 60s of the last century will remain an example of the fact that relying on computers is fraught with dangers. In the early Apollo flights, computers were used just like calculators that can perform a set of mathematical operations. Any defect that might occur in the software used was prohibited in the missions which use this computer for navigation not to jeopardize the astronauts' lives. Despite the warning signs that caused Neil Armstrong's fears upon his descent to the moon, the performance of the Apollo computer was completely successful, and this device established the rules of navigation in contemporary exploration systems. But how was the Apollo computer, called in English Apollo Guidance Computer (AGC), able to perform this historic role, despite its capabilities being millions of times lower than any smartphone in our contemporary world. Integrated circuits or microchips were essential in the development of computers of the size required to be placed on board spacecraft, rather than the large cylindrical computers that preceded them. The electronic chip was developed by Jack Kilby, of Texas Instrument, and Robert Noyce, the founders of Fairchild Semiconductor, and Intel, not the U.S. Space Agency, NASA. However, to meet the enormous demand, NASA and the U.S. military, which need the chips to direct its ballistic missiles toward the Soviet Union, accelerated its development. NASA and the Pentagon purchased 1 million electronic chips in the early 1960s, which encouraged manufacturers to create chips that lasted longer periods of time as opposed to the few hours that the initial chips lasted. The ability to manage numerous tasks at once is a strength of modern computers and smartphones, but the original computers had few jobs to do and were only capable of performing computations and replacing humans in these duties. But after the Apollo computer, everything was different. The suitcase-sized machine had to perform a number of crucial tasks, including navigation, oxygen and temperature control, as well as carbon dioxide purifying. The Apollo computer had to be quick in order to keep up with the spacecraft's journey around the moon and receive commands from the crew in real time, unlike earlier computers, which required users to input a series of computations and wait for the results, which occasionally took days to show. Additionally, NASA desired a separate computer because it feared the Soviets might obstruct communications between the crew and the ground control center. All of this called for clever information engineering. Engineers also started to go a step further than the punch cards in early computers. They invented 3 main elements, which are the operating keys that are currently in the cockpits of aircraft, and the control sticks that managed the system for the first time electronically, while the third element was similar to a keyboard called DSKY, which constituted a revolutionary invention in that era. While the lunar module was landing on the moon with Neil Armstrong and Buzz Aldrin, the Apollo computer siren sounded several times, giving the impression that the mission was doomed to failure. If this actually happened, the spacecraft would not have been able to correct its height, speed and orbit, and a possibility of crash may arise. But on the ground at the Houston Control Center, NASA team quickly understood that the alarm was due to a computer glut of information. All systems were working fine on the keyboard. Thanks to clever programming, the computer was able to reduce the handled tasks automatically and suspended some jobs to give priority to the important tasks needed to land on the moon. The performance of Apollo computer after reaching maximum load was a real breach.